July 29th, 2026, 11:17 p.m. 23 Ukrainian naval drones slice through the darkened Sea of Azov, silent, low, lethal. Russia's commanders in Mariupol have no idea. Their radar shows nothing unusual. What they don't know is that a 40-minute gap in their own detection net has been mapped down to the second by Ukrainian signals intelligence. And tonight, that gap is being used to erase 11 vessels from Moscow's Azov logistics chain. By the time Russian duty officers realize what is happening, 3 fuel tankers are already listening. The operation will last 72 hours. It will cost Ukraine almost nothing, and it will force Russia to reroute supply convoys 400 kilometers overland through roads already under HIMARS pressure. I'm your host at Steel Horizon, where we analyze the battles that change wars. What you're about to see is not a naval strike in the conventional sense. It's a textbook demonstration of how a smaller force, with no conventional fleet and no maritime air cover, turns an enemy's inland sea into a kill zone. Stay with me. The way this operation unfolded will rewrite surface drone doctrine for years. The Sea of Azov has always been a problem for Ukraine. Landlocked on 3 sides by Russian-occupied territory since 2022, it functions as Moscow's private logistics lake. Fuel, ammunition, construction materials for occupied fortifications in Zaporizhia and Kherson oblasts. All of it moves through Azov shipping lanes at a fraction of the overland risk. Russian commanders treated it as a sanctuary, protected by land-based radar arrays near Berdyansk and Mariupol, covered by rotary wing patrols, and patrolled by a mix of corvettes and armed patrol boats. The Azov was, in Russian doctrine, a controlled environment. That assumption cost them 11 ships. The Ukrainian operation, codenamed STALEVAKHVYLYA, or Steel Wave, was months in preparation. Ukraine's naval drone units had built something valuable from Black Sea strikes throughout 2025, a detailed operational database of Russian radar behavior, patrol schedules, and electronic warfare pulse patterns in coastal zones. The Azov presented a different challenge from the Black Sea. It is shallow, averaging only 7 meters in depth, and narrow enough that radar coverage from both the eastern and northern shores overlaps significantly during daylight operations. At night, with Russian patrol boat density lower and helicopter coverage reduced to minimum, a strike window was theoretically achievable. The question was finding it precisely enough to exploit it at scale. For months, Ukrainian SIGINT assets, including ground-based intercept teams positioned near Zaporizhia and drone-mounted signals collection platforms flying inside Ukrainian-controlled airspace, had been mapping Russian radar emissions in the Azov basin with granular precision. What they found was extraordinary. Russian radar operators along the northern Azov coast were running a maintenance protocol that created a predictable 40-minute window of degraded coverage, occurring approximately every 6 to 7 days, when adjacent radar stations handed off sector responsibility. During this handoff, each station briefly powered down its primary emitter for a diagnostic cycle, trusting the adjacent unit to cover the gap. The problem: both stations ran their diagnostics within the same 40-minute window on the same night cycle, leaving a corridor of reduced detection running roughly 60 kilometers along the central Azov basin. Ukrainian planners spent 6 weeks validating this finding. The gap appeared consistent across multiple observation periods. On the 7th validation week, July 21st, 2026, the planning team submitted the operational concept to Ukrainian Navy Command. Approval came within 48 hours. Which weapon system wins a naval drone engagement? Speed, payload, or stealth? The Magura V5 answers that question across all 3. Comment below. Which factor do you think mattered most tonight? A. Speed above 40 knots. B. 320 kilogram shaped warhead. C. Low radar cross-section. The answer shapes everything about how these drones were deployed. 23 Magura V5 surface drones were allocated to Steel Wave. The Magura V5 is a Ukrainian-designed unmanned surface vehicle, roughly 4 meters in length, with a fiberglass hull optimized for minimal radar return. Its jet propulsion sustains speeds above 40 knots in calm water. Its warhead, reconfigured for this operation, carried approximately 320 kilograms of explosive in a shaped charge configuration designed to penetrate below the waterline. The drones communicate via encrypted satellite uplink with a secondary radio relay as backup, and are piloted remotely by trained operators through a joystick and camera interface. What they're steering weighs several tons and carries enough explosive to open a ship's hull to the sea. The forward control station was established near Zaporizhia. It was staffed by 2 operator teams working in 4-hour rotations, 8 primary operators and 4 supervisors. Each operator managed a cluster of 2 to 3 drones with clean handoff protocols between rotation shifts. Communications infrastructure was hardened against jamming using frequency hopping across multiple satellite bands. Here's the part that doesn't make sense on the surface, at least until you examine the electronic warfare dimension. The Azov basin in mid-2026 was saturated with Russian jamming emitters. Ground-based Krasuka series EW systems near Berdyansk projected interference across broad frequency bands, and airborne jamming from helicopters out of Mariupol added another suppression layer. Ukrainian operators had probed this environment between March and May 2026 with smaller reconnaissance missions. What those probes revealed was critical. The Krasuka systems prioritized airborne frequencies, leaving the lower-power maritime relay bands relatively clear. Ukrainian engineers had quietly retuned Magura V5 communications to exploit exactly those bands before Steel Wave launched. There was still a serious problem. 3 days before launch, July 26th, one of the forward relay nodes forming the communications bridge to the eastern sector went offline. A Russian artillery barrage had damaged the antenna array. Without the relay, 7 of the 23 Magura V5s assigned to the eastern corridor would be operating near the edge of reliable control range during the most critical phase of the strike. The planning team had 72 hours to solve the problem or cancel the operation. They solved it. Ukrainian signals teams installed an emergency relay node, a compact vehicle-mounted unit, at a position closer to the contact line, accepting additional detection risk. The relay restored coverage. The operation remained on schedule. But the team knew, if Russian forces detected and hit that relay during the strike, those 7 eastern drones could go dark mid-mission. Stay with me, because what unfolds in the next phase of this story is exactly why Ukrainian naval drone crews have become the most dangerous maritime force per capita on Earth. The night of July 29th was calm by Azov standards. Wind speed at the launch point measured approximately 9 kilometers per hour from the northwest, producing minimal wave chop. Favorable conditions for surface drones, where hull stability directly affects targeting accuracy on final approach. Drone launch began at 11:17 p.m. Not simultaneously, sequentially, in timed intervals designed to prevent the drones from bunching into a single radar return. 1 drone entered the water every 90 seconds. By 12:19 a.m. on July 30th, all 23 Magura V5s were underway. The 40-minute radar gap was projected to begin at 12:43 a.m. The drones needed to reach assigned positions, spread across a 60-kilometer strike arc, before the gap opened, then accelerate to attack speed the moment Russian detection capability dropped, at 12:41 a.m., 2 minutes ahead of projection. The Ukrainian EW team detected the diagnostic shutdown beginning at the first Russian radar station. The gap was opening early. Operators received the order simultaneously: accelerate to attack speed. 23 Magura V5s pushed to full throttle, hull riding across the dark Azov surface at over 40 knots. Russian patrol vessels in the area, 2 Raptor-class boats on a standard circuit near the northern shipping lane, had no realistic time to respond even if they detected acoustic signatures. At those speeds, the window between first detection and impact on a vessel stationary at anchor is under 90 seconds. The Raptor-class boats are capable interceptors in calm conditions. Tonight, they were spectators. How many vessels did Ukraine destroy in this 72-hour operation? A, 8 vessels. B, 11 vessels. C, 14 vessels. The answer, confirmed by satellite imagery analysis, is coming at the end of this breakdown. The strike unfolded in 3 waves, each assigned to a specific vessel cluster drawn from Ukraine's target list. That list had been built from weeks of commercial SAR satellite passes over the Azov basin, cross-referenced with AIS transponder data and human intelligence from sources inside occupied territory. 11 vessels were designated high-priority targets. 6 fuel tankers supplying Russian ground forces in Zaporizhia Oblast, 3 logistics barges carrying construction materials for fortification work near Tokmak, and 2 military support vessels, including 1 armed corvette assigned to Berdyansk patrol duties. Subscribe to Steel Horizon if you want to understand how modern warfare actually works. Because what you're watching tonight is the future. A nation with no conventional navy turning an enemy's internal sea into a kill zone using engineering, intelligence, and precision. The first wave, 7 drones, targeted the fuel tanker cluster. These vessels were anchored approximately 18 kilometers north-northeast of Berdyansk, their position confirmed by a Ukrainian reconnaissance drone pass 6 hours before the strike. The tankers were running minimal lighting under Russian maritime security protocols. It didn't matter. Magura V5s carry electro-optical and infrared targeting sensors in the nose section, capable of discriminating vessel silhouettes against water background and minimal ambient light. First contact, 1:02 a.m. Drone Sigma 4 struck the largest tanker, a Volga-class fuel barge, approximately 80 meters in length, carrying an estimated 1,200 metric tons of diesel fuel, on its starboard bow, 2 meters below the waterline. The shape-charged warhead detonated against the hull, punching through the steel plating and igniting the fuel cargo in the forward compartment. The explosion was visible for kilometers. Ukrainian operators described a fireball that briefly overwhelmed the drone camera's exposure compensation. The tanker listed immediately. 4 more tanker strikes followed within 6 minutes, all connected. Within 8 minutes of first contact, 5 fuel tankers were burning or listing in the northern Azov basin. The second wave was already incoming. What stands out about this operation is how much its success depended on the intelligence architecture, not the hardware. The Magura V5 is an exceptional weapon, but it was the 6 months of SIGINT collection, the patient mapping of radar gaps, the engineering fix for the damaged relay node, and the disciplined sequencing of 23 vehicles across a 60-kilometer arc that made the difference. Hardware wins engagements. Intelligence wins operations. Real tactics, real consequences. Steel Horizon. The second wave, 9 drones, targeted the logistics barges. 2 of the 3 barges had been underway at the time of the strike window, moving slowly under tow. Ukrainian operators had to perform real-time target updates, recalculating intercept headings based on live camera data and GPS position feeds, simultaneously managing final approach runs against the stationary third barge. One of the moving barges executed a course change at 1:14 a.m., bringing it temporarily broadside to a Magura V5 already locked on its original bow aspect. The operator, working with less than 20 seconds of decision time, manually adjusted the intercept course. The drone connected amidships at 1:17 a.m. The barge, loaded with prefabricated concrete panels for Russian fortification work, took the hit, broke its tow line, and began settling stern first within 4 minutes. If you believe tactics win wars, type Steel Horizon in the comments. Because what these Ukrainian operators demonstrated tonight is that precision defeats tonnage every single time. The third barge was struck by 2 drones within 40 seconds of each other, bow and stern simultaneously, the dual impact protocol developed from Black Sea strike lessons in 2025. It went down within 11 minutes. Then came the complication the planning team had worried about for 3 days. At 1:22 a.m., the emergency relay node near the contact line went offline, not from Russian fire, from a power failure in the vehicle-mounted generator. 3 of the 7 eastern drones instantly lost their uplinks entirely. Operators at Zaporizhia had trained for this contingency. Sigma 17, Sigma 19, and Sigma 22 immediately fell back on their autonomous terminal guidance protocol, a pre-programmed behavior that locks onto the nearest vessel-sized thermal return above a minimum heat threshold and maintains intercept trajectory. The drones did not need to be guided to their targets. They found them. Sigma 17 struck the corvette, the Russian vessel, a Cerna-class landing craft of the Azov flotilla, approximately 45 meters in length and carrying a 30 mm autocannon, had detected acoustic signatures from approaching drones at 1:19 a.m. and had begun an emergency course change, increasing speed and turning to present its bow to the bearing of the incoming sounds. Its captain attempted to ram. According to intercepted communications later shared by Ukrainian military intelligence, the corvette commander ordered full ahead and tried to steer directly into the drone's path, intending to deflect or swamp it with the bow wave. It didn't work. Sigma 17's autonomous guidance system interpreted the course change as a target maneuver and recalculated intercept geometry in real time, adjusting heading to maintain a beam aspect intercept. The corvette's bow turn brought it broadside. Sigma 17 struck it amidships on the port side, directly into the engine compartment, the hull section pre-designated as the optimal impact point in the pre-mission target study. The corvette's engines died instantly. It began taking water through the engine room breach. Satellite imagery acquired 6 hours later showed it listing 28 degrees to port, partially submerged. What would NATO have done differently in this scenario? A naval force with full maritime air coverage and anti-drone countermeasures trained against surface USVs? Comment your analysis, because the gap between how NATO thinks about drone threats and how Ukraine has actually solved the problem is one of the most important doctrinal questions in modern maritime warfare. The remaining Eastern drones with active uplinks guided their attack runs against a military support tender accompanying the corvette. Both drones connected within 90 seconds of each other. The tender was unable to operate under its own power within 6 hours of the strike. By 2:04 a.m. on July 30th, 2026, the active strike phase of Steel Wave was complete. 11 vessels hit, 3 sunk within the strike window, 3 more confirmed, capsized, or grounded within 6 hours, 5 disabled and unable to operate under their own power. One detail that stuck with me when reviewing the post-operation analysis: the intercepted Russian communications. The duty officer at Mariupol Naval Command is recorded asking 3 times in 4 minutes whether the explosions were from Ukrainian shore-based artillery rather than drones. Surface drones penetrating the Azov basin at scale simply wasn't in his operational mental model. By the time the correct threat picture was established, the strike was over. Here's the take that will probably get us flack. Russia's Azov logistics failure wasn't just an operational inconvenience. It was evidence of a catastrophic doctrinal failure at the institutional level. Moscow had 4 years after 2022 to develop serious countermeasures against Ukrainian surface drones in the Azov basin. Drone nets, active jamming arrays tuned to USV communications frequencies, rapid response interceptor boats pre-positioned along key shipping lanes. They built none of it. They trusted the radar coverage. They treated the Azov as a sanctuary without doing the actual defensive work to make it one. That is not an intelligence failure. That is a leadership failure, and 11 ships on the Azov floor are the receipt. Here is the second question this operation forces us to confront, and it is bigger than the tactical result. What is an inland sea worth, strategically, when the force that controls it on paper cannot protect its own shipping? The Sea of Azov, as a Russian logistics asset, is now degraded. Moscow will respond. The question is whether its response can outpace Ukrainian innovation or whether the Azov joins the Black Sea Fleet's recent history as another body of water where Russian maritime doctrine failed to adapt fast enough. Fuel convoys that had previously moved via Azov tanker now faced a 400-kilometer overland reroute. Ukrainian HIMARS units in Zaporizhia Oblast had spent the preceding 2 months pre-registering fire on the road networks those convoys would be forced to use. Russian logistics planners were walking their fuel trucks directly into a prepared artillery kill zone, and they knew it. Intercepted communications from Mariupol Command in the 72 hours following Steel Wave include explicit acknowledgement that the overland routes are, quote, under systematic fire pressure. Russian occupied forces in the Tokmak and Polohy sectors, the ground formations most dependent on the Azov supply chain, began reporting fuel shortages within 5 days. By August 2nd, Ukrainian military intelligence confirmed that at least 2 Russian combined arms battalions in the Zaporizhia direction had reduced vehicle movement to preserve fuel reserves, degrading their tactical mobility at a moment when Ukrainian ground forces were pressing the contact line. Russia's Azov flotilla lost its last functional patrol corvette in the basin, the remaining Russian naval presence, a handful of Raptor-class patrol boats and Cerna-class craft, lacks both firepower and sensor capability to constitute a credible counter-USV force. Ukrainian drone units can now operate in the Azov basin with significantly reduced threat from Russian surface vessels. Total estimated value of destroyed or disabled tonnage. Ukrainian military sources put the figure at approximately $180 million. Independent maritime analysts reviewing publicly available vessel registration data produced estimates ranging from 140 to 210 million, acknowledging uncertainty in cargo valuations for the fuel tankers and barges. Will Ukraine launch a second steel wave-scale Azov operation before Russia can rebuild its defenses? Comment why yes or no, because the window may be shorter than you think, and the answer determines whether the Azov becomes a permanent kill zone or a contested space Russia can eventually reclaim. The Magura V5's autonomous terminal guidance, the feature that saved the Eastern strike wave when the relay node failed, is a significant doctrinal development. Surface drones that complete their mission independently after communication loss are fundamentally harder to defeat through electronic warfare alone. Russia's Krasuka jamming achieved partial success during the strike. Ukrainian operators estimate 3 to 4 drones experienced degraded control moments. All 3 that lost full connectivity still hit targets via autonomous guidance. The lesson for Russian EW planners is uncomfortable. Jamming the communications link is no longer sufficient to stop a modern Ukrainian USV. The 4-hour crew rotation system deserves specific attention. Operator fatigue is a known vulnerability in extended drone operations. By designing the mission around strict rotation protocols and assigning each operator a defined vehicle cluster with clear handoff procedures, Ukrainian commands sustained peak operational performance across a 72-hour window that would have degraded significantly under a single, continuous crew. This is a human performance innovation, not a hardware one. And it is exactly the kind of thing that does not appear in weapons specifications but determines outcomes in actual combat. The Sea of Azov is quiet now, quieter than it has been in years because there are fewer Russian vessels moving through it. The wrecks of 11 ships rest on its shallow bottom or along its northern shoreline, where the Azov's limited depth brought them to rest in partial submersion, visible in satellite imagery as dark forms against the pale Azov mud. Real tactics. Real consequences. Steel Horizon. The quiz answer. How many vessels did Ukraine destroy in Operation Steel Wave? The correct answer is B, 11 vessels. 3 sunk within the strike window. 3 more capsized or grounded within 6 hours. 5 disabled and unable to operate under their own power. All confirmed by satellite imagery cross-referenced against Ukrainian military reporting. The 8-vessel figure appears in early open-source accounts that predated the full satellite assessment. The 14-vessel figure is not supported by confirmed imagery. 3 questions to close. Was the decision to proceed with the degraded Eastern relay node, rather than delay for a full repair, the right tactical call? 7 drones on autonomous terminal guidance is a significant deviation from the planned command architecture. It worked. But what if Russian EW had jammed the autonomous guidance frequency as well? The planning team made a calculated bet. Given the 6-month investment in identifying the radar gap and uncertainty about whether the gap would recur reliably, delaying was arguably the riskier choice. Could Russia have prevented this? The radar maintenance gap was a doctrinal process, not a technical malfunction. A revised maintenance schedule, staggering diagnostic cycles to ensure continuous coverage, would have closed the window. Russia maintained this protocol for years without anyone exploiting it at scale. The failure was not in not knowing the gap existed. The failure was in not treating it as a vulnerability that a sophisticated adversary might eventually find and use. What would you have done differently? Put yourself in the position of the Ukrainian naval drone commander authorizing Steel Wave. 23 vehicles, a 40-minute window, a relay node 3 days from failure. Would you have delayed for the repair? Would you have concentrated on fewer, higher confidence targets? Would you have accepted the autonomous guidance risk on the Eastern Wave as the actual commanders did? The decision tree is genuinely difficult, and the fact that it worked does not automatically mean it was the only valid approach. Subscribe to Steel Horizon, because we break down the battles that textbooks will study for decades. Steel Wave will be in those textbooks, as the engagement that demonstrated surface drone swarm tactics at scale in a constrained inland maritime environment, and as the moment Ukrainian naval drone doctrine matured from opportunistic single strikes into coordinated operational level capability. The Sea of Azov is quiet now, but the wrecks remain. 11 ships on the shallow bottom, visible in satellite imagery as dark forms against the pale mud. Reminders that modern warfare punishes tactical complacency without mercy, and that a force willing to spend 6 months patiently mapping a 40-minute gap in enemy radar coverage will eventually find a way to use it. Stay vigilant.